Hey everyone, in this video we're going to go through the 2017 exam 1. Just looking at question 7. I'm not sure whether it's going to be a long video or not, but hopefully not too long. I just read through just these first two, and I think during reading time, if you saw these questions, you shouldn't assume that they're difficult just because they're towards the end of the exam. They're actually pretty straightforward and quite achievable, especially part A. So just remember, when you've got reading time, it's a chance for you to actually think, okay, which questions are possible? All right, which ones can I actually do? Which ones should I actually spend my time on? And remember, when there's difficult ones, you maybe put a little asterisk next to it and come back to it. All right, so let's have a look at part A. State the range of f. So I've got a square root graph that's been shifted to the left 1. So let me just sketch that. So it's going to look something like that. And so this is our domain, which is different to the implied domain. So it's actually been restricted a little bit. So it's going from 0 onwards. So when we're doing the range, we do have to take into consideration things like that. All right. If we just took it for granted and wrote the implied domain, it would obviously be wrong. So at this point at x equals 0, just substitute that in. So f of 0 is equal to the square root of 1, which is just 1. So your range, we're going to include that. So 1 to infinity. Just make sure you've got a square bracket on the 1 because the 0 is included, and infinity will always have a curved bracket. All right, part B. So we've got G with this set domain, and this G is a parabola and C is less than 0. So find the largest possible value of C such that the range of G is a subset of the domain of F. Okay, so we've been given the domain of F, which is good. So now we just have to work out the range of G. Now, I know it's a parabola, and I always think if I can draw the graph, it just helps me see what is happening. So we can factorize this one. It's actually not a difficult one to factorize. So two numbers that multiply to give us 3 and add to give us 4. So it's x plus 3, x plus 1. So we've got x-intercepts at -1 and -3. So our the x-coordinate of our turning point is at -2. So halfway between the two of them. You could also use the formula -b on 2a, and you could get your -2 that way as well. All right, so at x equals -2, so f of -2 to get our y-coordinate of the turning point. Oops, sorry, that was a bit wonky. Let's get rid of that. 4 times -2 plus 3. All right, so 4 minus 8 plus 3. So what is that? -4 plus 3, so -1. All right, so I'm just going to continue sketching it so we can see what it looks like. All right, so it has to be a subset of the domain of f. So f goes from 0 to infinity. So I might just do this in a different color. All right, so, oh well, that continues to infinity. Maybe I'll put an arrow up there. So basically, we have to cut it off there. We can't have anything below that axis. And C is a negative value, so we're actually only wanting this part here. So your value of C is going to be -3. All right, for the value of C found in part BI, state the range of G of X. All right, so I'm just for part 2 going to look at f of x and g of x, the domain and range. So I'll write I don't have much space here, so let's just do the domain first. So for g of x, we had from -infinity to -3, and then for f of x, we had 0 to infinity, and the range for that was 1 to infinity. And then the range for g of x was going from 0 to infinity. Alright, so we want the range of f of g of x. So the range of f of g of x is equal to the range of f of x. So it's going from 1 to infinity. Alright. Let h equal, sorry, not h equal, h of x is equal to x squared plus 3. State the range of f of h of x. Alright, I'm just going to check that it is defined, so I probably don't need to do that, but I will. So, just like I did before, I'm going to write the range first. And we've got the domain up there as well. And then the domain is R, and what have we got here? We've got a parabola that's been shifted up 3, so it's going to be 3 to infinity. Alright, so for it to be defined, f of h of x, so the range of h of x has to be a subset of the domain of f of x. So the range of h of x is 3 to infinity, and then the domain of f of x is 0 to infinity. Alright, so that's, yep, that fits, which is good. Okay, so let's just do the composite function. So that just means we're substituting in h of x into f of x. Scroll up to get f of x, square root of x plus 1. So it's going to be x squared plus 3 plus 1, which gives me x squared plus 4. Now remember, if we're doing, alright, sorry, I got distracted again. Alright, so let's have a look at our original function, the, where are we? X plus 1. So even if we did x plus 4, let's have a look at that, the square root of x plus 4. So what happens before we square the x? So we're crossed like this, all right, and that's going to be negative 4. If we're squaring that x, basically anything in this negative side becomes positive, all right, so it's never going to go down like that. It's going to be positive, well, I shouldn't say positive, it's still going to be on the negative side, but you're adding it to 4. So it's kind of going up now as opposed to going down, right? Because you're taking this value here and now you're adding 4. So it's going back up basically. So what we need to know is this point. Let me do it in a blue dot. This point here. All right, and we know that with our graph, all right, let's just let x equal 0 because that's the y-intercept. Square root of 4 is 2. So this point here is 2, and that means our range is going from 2 to infinity. So a bit of working down here. So our range of f of h of x is from 2, and includes 2, to infinity. Now, just going back up, I just wanted to explain the difference because you're probably thinking, well, in the previous one, you said it was the same as the range of f of x. Now, the only reason it is because your domain of f of x and your range of g of x are the same. All right, so that means the range of f of x, sorry, the range of f of g of x is going to be the same as the range of f of x. Whereas in this one, we can see they're not the same. All right, so we actually then have to think about, well, what does this graph actually look like? All right, and we can do it from there. All right, I'm going to leave it there. Oh, no, did we have any more? Sorry. No, that was it. All right, bye, guys.